Hello and welcome to this lecture on Virtual Environments 1 and 2. So if we just start off thinking again about the course, computer vision and virtual environments is what we consider in the first part of this course. Computer vision and model control being the course, of course. Computer vision, so what have we got there? Just to recap over what we talked about before, we're capturing images with industrial cameras, and the difference between industrial cameras, of course, and the kind of cameras you might buy down at the supermarket or wherever is that industrial cameras are calibrated, hardened, repeatable. They're in sort of metal cases normally, so they're more robust and more suitable for an industrial environment. So that's what you've got with image capture, and then as I say, we interface that using USB 3 nowadays a lot of the time to the computer, and we start processing the image, capturing the images and processing them. And one way of doing that, of course, the easiest way of doing that probably is with Vision Assistant. But Vision Assistant is just a high-level shell, really, that works with iMac Vision tools. So iMac Vision tools are the vision tools that come with LabVIEW. So years ago, when we first got into this EWE, we bought all this LabVIEW software, about 1999, I think it was. And we bought LabVIEW, then we had to buy the iMac Vision tools to go with LabVIEW. And then some people wanted to do some C programming, so we had to buy LabWindows CVI for them. And then we had to buy all of the iMac tools again for LabWindows CVI. So it can get a bit expensive, but one thing you would say is that it's all optimized for the user. And also, of course, what we pay is a lot less than industrial rates would be. Just talking about optimization, it says easy to use and speed optimized there. So in other words, what we're saying there is that the VIs, the Vision VIs, which is what the iMac Vision is, have been optimized to be easy to use, and the coding is optimized so that they work as quickly as possible. That's why in general I'd recommend using these VIs if you possibly can, rather than try to code the functions yourself in just raw code. Because these guys are programmers who spend their whole lives trying to speed these routines up, and they've got them working pretty efficiently. And you don't have to worry about all the details of programming, of course. You just use the VIs in a more straightforward way. It says here, alternatively, the image can be converted into an array, and then virtual instruments can be written to analyze the data in the array, generally slower but more powerful and flexible. So that's what I'm talking about really then a minute ago. You could just turn it into an array and start analyzing the elements of the array. But I wouldn't recommend doing that unless you have to, because really, as I say, the power and utility of the VIs that are designed for image processing is worth making much use as possible of that, because they're all very useful. But there are some times that they don't give you exactly what you want to do, and then you have to do something like that. You have to implement it yourself. But again, you want to stay with 2D image processing as long as you can, even in a 3D application. Stay as long as you can in 2D. Then if you need to go to the 3D data, you can do so. So virtual instruments, in LabVIEW, virtual instruments can be made which are similar to benchtop instruments but are computer-based. And we talked about that a bit. The virtual instrument idea also means implementing an instrument, but it's not a real physical instrument in the lab. It's not a real piece of hardware kicking around in the lab. It's just a program on your computer, which you might have on the desktop. You double click, down it comes, and then you have the card installed in the PC so that you can input and output data as you want to. Could be like a multimeter would be a simple example of it. I think I showed that on one of the slides. But scientists love this because they want to rig up instruments that do specific things they're interested in. They don't want to use very standard instruments a lot of the time. They want to do some particular analysis and particular data capture. And of course, you can do that in LabVIEW. So it's great for scientists and engineers to be able to customize their instruments to exactly what they want. Use of the control panel and the diagram simplifies control and data output for the VI. So the control panel, of course, where you, as we said, where you create your controls, inputs, and then your indicators, and then the diagram which shows how the code actually operates, the block diagram. This is nice and straightforward. I mean, because creating a control, like an input, like a knob you alter to vary a value, it's just creating it on the front panel. It automatically appears in the block diagram. You don't have to do any programming at all. So it's quite easy to use, LabVIEW, I think you'd have to agree. As it says here, the graphical programming G language is easier to learn than text-based languages, particularly C. In fact, they say that it's about 6 times quicker to learn than C programming, for example. Consequently, a G language allows the user to focus their effort on implementing the algorithm of the VI. In C, around half of the effort needs to be spent on programming aspects. So, in C, you're worried about pointers and variables and all sorts of data-related, programming, computer-related, rather, considerations like the stack, for example. And if you do something like you overrun, you try to read too much data into an array, and so you get some sort of esoteric error coming up. But with LabVIEW, it would tell you what's going on. It'd be much easier to find out what's going on. And you wouldn't have to spend that half of the effort on programming aspects that you would do with something like C. So virtual environments then, the first concept, well, that's what we're talking about, computer vision. But the first concept of virtual environments is where a proposal for, say, a manufactured product can be generated as a solid model, and then ray tracing can be used to generate a photorealistic image of the object in various environments and positions to check function and aesthetics before manufacture. This is what we were talking about in one of the prior lectures, wasn't it? You've got this product, but you haven't made it. All you've got is a design and a solid modeler. But then you can use that. You can move virtual lights around. You can put different bitmaps on surfaces, and you can have shadows and textures and all sorts of things. And you can make it very realistic, and you can take it as far as you want on the physical realism of it, involving physics models of the light passage and refraction, if you want, and all the rest of it. So you can make some very realistic images, and that's where the term photorealistic comes in. The idea is you couldn't tell it apart from an actual photograph. And then you have a design, and then you can appraise it in various environments or situations to check not just what it looks like, but how well it might function in those environments. You can check aesthetics and functionality by analyzing the solid model. So that's a virtual environment application really there. Now I've got a second concept of what virtual environments is about. Virtual environments 2. So virtual environments 2, LabVIEW allows a user to publish a front panel of a LabVIEW program for use in a standard web browser. So this is a second concept in this course of virtual environments. Once published, anyone on the web with the proper permissions can access and control the VI from the local server. In fact, my wife was working at Bristol University on some work on earthquake analysis, and some of the instrumentation she could control from home by using remote desktop. But the advantage of this over other ways of doing it is that you just drag down from the menus what you want to do and how you want to control different functions, rather than having to start doing programming. It's all designed for it. If the VI controls a real world process, such as parts manufacture and inspection, then LabVIEW remote panels allows the process to be monitored and controlled remotely. Okay, quite useful. Could be useful if the experts of the process are limited in number or located in, say, a different country. This could produce savings such as reduction in labour costs, scrap and downtime, or improved accuracy. Now that could be, an example of that could be some company where they're designing the products here in the UK, but they manufacture them in Asia. One example that comes to mind is, I might have mentioned before, is of course Dyson in Malmesbury in Wiltshire, where he's still got his design headquarters there, so he can do the design, but the actual manufacture is going on in Malaysia. But he can do all this analysis of the design using virtual environments before he's actually made anything. And then when they get around to manufacturing it on the production plant, he can start using suitable cameras and lighting to capture images of it in different situations and see how they compare with what he originally had in mind with the manufacturing. So that's the how the virtual, and that could all be controlled from Malmesbury, even though it's going on in Malaysia, just over the internet. Another application then for remote learning is where a tutor can monitor and control a lab session for many students from a remote location. Enabling remote panels. Well, this is the procedures we had here. Load the VI you want to publish, select the web publishing tool from the tools menu, select the start web server button. Once the web server is activated, the actual HTML document needs to be created and saved so that it can be accessed remotely. All the administrative solutions are available to produce a complete remote control of a process. For example, remote panel connection manager is used to manage client traffic to a specific front panel. So remote panels can take a VI and transform it into a remote monitoring and control facility, to cut a long story short. And that's what we're talking about a second ago. The manufactured components placed in its proposed location and viewed by a camera. The camera and associated lighting can be controlled by a VI, which could be controlled remotely. The images could be compared to the images from the ray traced virtual environment that you started off with originally. And this is all controlled from a browser located in a different room or even country, because on the internet it doesn't really matter where you're located. In this way, products could be developed and evaluated remotely. Could be useful in industries where experts are limited in number and are located away from the production facility. Designers in Europe or the US with the production in Asia, for example. Remote control of VRs has many teaching applications, some of which I've got a handout, which I also put onto Blackboard, which we'll have a quick look at in a minute. But we have that where it gives one or two examples of teaching applications. Another thing which you could argue is a remote application of virtual environment is something like the Da Vinci surgery machine. I don't know if you guys have seen this machine, but we've got some research going on in the BRL on robot surgery. And there's this machine called the Da Vinci, which is made in the States. And it's designed with a sort of stereo vision for the surgeon, and these controls, using these handles, he controls these robotic cutters and manipulators. There's no force feedback, which is one disadvantage of it at the moment. They're trying to get that implemented, but you get this stereo vision, and you're doing it remote, and it overcomes the problems like with shaking of the hands or something like that, because you can do very precision procedures using these servos. And of course, the actual surgery could be in a different room or a different city or even a different country altogether from this surgery. This could be very useful perhaps in places like Australia, where you've got experts in Sydney, but maybe needing some procedures in the outback somewhere. Rather than keep travelling around, you could just install one of these machines at a health centre in Western Australia, say, and then you could do it over the internet. So there's all sorts of applications where remote control is really, through the internet, is really a hot subject nowadays. And this is one way of doing it for a low cost for a lot of companies, really. LabVIEW remote desktop. Overview then. The internet has opened many new opportunities and uses for personal computers and workstations across every industry and application area. Scientists and engineers are finding that important functions can be performed across the internet, such as research, publishing conclusions, displaying data across the web, archiving source code versions, and scheduling for test development teams. In addition to taking advantage of the internet, Virtual Instruments are addressing remote or distributed applications more and more. Using the National Instruments LabVIEW Internet Development Toolkit, you can easily incorporate a variety of electronic communications capabilities, such as XML, CGI, and FTP transfers into your virtual instrumentation applications. So that's just like a little introduction to what you can do with virtual environments with LabVIEW. And there is a document, as I said a minute ago. I do have a document which gives a little more background. So I won't read all this out to you because you can read it yourself, of course, but I'll try and pick out one or two highlights maybe. Laboratories, which are found in all engineering and science programs, are an essential part of the education experience. Not only do laboratories demonstrate course concepts and ideas, but they also bring the course theory alive so students can see how unexpected events and natural phenomena affect real-world measurements and control algorithms. However, equipping a laboratory is a major expense and its maintenance can be difficult. Teaching assistants are required to set up the laboratory, instruct in the laboratory, and grade laboratory reports. These time-consuming and costly tasks result in a relatively low laboratory equipment usage, especially considering that laboratories are available only when equipment and teaching assistants are both available. What if some of the basic laboratory experiments could be made available 24 hours a day, 7 days a week? What if students could have access to experiments from their home or student dormitories? What if a professor wanted his students to take a close look at classroom demonstrations? What if a professor wanted to make a research demonstration available to students and others at irregular times? What if a professor driving a complex equation for some application wanted his students to try different sets of parameters to bring out the essence of the model? What if a professor wanted his students to see an electronic circuit in action and even give them control over the operating parameters? What if a research team wanted to make their expensive research equipment available to others when they went home for the evening? All of these and many more exciting applications are now achievable with the new technology available from NI. LabVIEW remote panels. With this standard feature of LabVIEW, a user can quickly and effortlessly publish a front panel of a LabVIEW program for use in a standard web browser. Once published, anyone on the web with the proper permissions can access and control the experiment from the local server. If a LabVIEW program controls a real-world experiment, demonstration calculation, and so on, LabVIEW remote panels turns the application into a remote laboratory with no additional programming or development time. I think that last bit is very important there because There's lots of ways of doing this kind of thing, but being able to do it without requiring programming or a lot of development is very attractive to people who just want to get across what they're doing rather than turning it into a huge programming project. Now here we've got an example on distance learning. I won't read it all out, I'll leave it to you. So we're attaching a computer through the internet. And then we can go on to current remote laboratory successes, internet-based automation and measurement solutions. This was a little while ago, of course, it's been developed since then. Stanford University, it's a great place if you get a chance to go there, Stanford. Students logged onto a remote optics laboratory to conduct experiments to measure physical properties of a laser diode, for example. CyberLab provides not only monitoring and control features, but also laboratory scheduler, reference library, analysis tools. The NI LabVIEW Internet Toolkit is used to create CGI scripts for communication and control between the remote browser and the host server. The live embedded images are provided using NI IMAX software tools and an NI PCI, of course, image acquisition board. Nowadays, it would be, wouldn't even need the acquisition board. You just plug it straight into the PC. And then they're doing their experiments. Another example going on at the Swiss Federal Institute of Technology. Mechanical system being demonstrated for students. At the University of the States, virtual laser laboratory. 10 experiments, DC motors, you can read through all this. National Instrument Solutions, LabVIEW remote panels, more information on it there. Yeah, so you don't have to bother with things like extensive Java programming that you used to have to do to get these things working, you just use LabVIEW. The only disadvantage, I suppose, of like LabVIEW is it is proprietary equipment and all the programs and so on are particular to National Instruments. But then again, if you were using something like Lab Windows CVI, still all the routines, subroutines you'd be using would all be implemented the proprietary National Instruments analysis. So, you know, if you want to get something which isn't subject to having to pay royalties or being tied into a particular software supplier like National Instruments, you would probably want to do something like recode it in OpenCV, which is an open source, which has routines as well for doing various image processing tasks, for example, which are all public domain. So the advantage of that is you wouldn't have to keep, if you sold a system written in that, you wouldn't have to keep paying royalties to NI. So what we do a lot of the time is that we do prototyping of systems in LabVIEW, and maybe also analysis prototyping in MATLAB, using something like the Deep Learning Toolbox, for example. And then when we've got it working, and we know where it's working, we would try to recode it as something like OpenCV so that we could be sold by a company we're collaborating with, and they wouldn't have to keep paying royalties to National Instruments or the MathWorks, which could be putting them off in the long term, could be expensive. So it's very much a research and rig development tool, really. Enabling remote panels, I won't read it all out, but it's web publishing tools and all the information is there. You can look this up on ni.com, you get the latest information on what you can do with this. Client application control. Releasing control, you want to let people access it when they've got the right approvals, code names. Connection manager, it's all been developed there. You won't need to necessarily get into this. I'm not going to ask you in the exam to start implementing programs using this, but I want you to be aware of the capabilities of it and the kind of things you can do with software like LabVIEW. Web server configurations, application security, visual feedback, implementation. Summary. Distance learning remote laboratories are used extensively in academia to enhance classroom lectures, share research equipment, and supplement the learning process. Typical laboratories have relatively low usage, as we said a minute ago, and remote laboratories can eliminate some of the barriers found in traditional laboratories. Remote laboratories can remove the need to have a teaching assistant on hand, reduce the costs associated with traditional laboratory, and also make it available 24 hours a day, 7 days a week. LabVIEW now has revolutionary new technology that makes the creation, implementation, and administration of a remote laboratory very simple. Remote panels can take a LabVIEW program and transform it into a remote laboratory with a few simple mouse clicks. There is no longer any need for additional programming to enable your laboratory for the web. and control of the LabVIEW remote laboratory is exactly the same as it would be on the local server. LabVIEW also contains all necessary administration and security tools to create a complete LabVIEW-based learning, distance learning, remote laboratory solution. So that's your little bit of an introduction to what you can do with remote panels in LabVIEW. So that's the end of this lecture. I just wanted to give you an introduction to just a reminder of where we're coming from with computer vision, the kind of things we can do, and the way we do them. We're trying to basically capture scenes to analyze and measure certain parameters which are critical for various companies for various reasons. And then I wanted to go on a bit about the two means we have for virtual environments, being the virtual, the virtual instrument and then the virtual distance learning with remote control. Of course, there are limitations to what you can do with this kind of technology, because sometimes if you're trying to control robots remotely over the internet, there are certain lags that occur over the internet protocols which can cause certain control problems. So even something like LabVIEW remote panels would have issues with that kind of thing. But there's a lot of research going on in that, and we're doing quite a lot in the BRL about that. So there's all sorts of potential. But there's many things you can do. You don't need to be always doing dynamic robot control. There's lots of things you can do with something like remote panels to really get very, very useful remote monitoring and remote control. So that's it for this lecture. Thanks very much for watching, and I'll see you next time.